Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the specimen paper of the Cambridge 9709 paper 3, which is a pure mathematics 3 paper. And this question here is about differential equations. So we're told about a chemical reaction where you have a compound X which is formed from two other compounds Y and Z. So it says the masses in grams of X, Y and Z at present at time t seconds after the start of the reaction are X, 10 minus X and 20 minus X. So the mass of X is X, small x, the mass of Y is 10 minus X, and the mass of the compound Z is 20 minus X. Alright, they've told us that at any time the rate of formation of X is proportional to the product of the masses of Y and X present at the time. Okay, so the rate of formation of X. So you can say the rate of change of the mass of X with respect to time is equal to, or is proportional to, so let's write it as proportional first. So is proportional to the product of the mass of Y and the mass of Z. Okay, so we know the mass of X is X. That's where this dx dt comes from. So we can replace mx with X. So we can say dx dt. The proportional sign can be replaced with equals k times. And the mass of Y is 10 minus X. And the mass of Z is 20 minus X. Okay, so that's what we got so far. Now, what it seems now, we need to find what X is. We need to find that X is 0.01 and we're done. So how do we find that? Well, we can use this information here. We know that when X is 0, dx dt is 2. So when X is 0, we know that dx dt is 2, as I've told us. So we can replace dx dt with 2. That's k times, you got 10 minus 0 and 20 minus 0. So we have 2 equals 200k. Therefore, k is equal to 2 over 200, which is 1 over 100, which is 0.01. So we worked out the value of k and we have shown. So therefore, we can say dx dt is equal to 0.01 times 10 minus x times 20 minus x. That's exactly what we had to show. Okay, that's what we had to show. So there's the answer to part A. Now for part B, it says solve this differential equation. Solve this differential equation and obtain an expression for X in terms of t. Okay, so they've basically told you what solving a differential equation is. It means if you have, for example, something which has dy dx in it, you've got to end up with x equals some y equals some function of x. Okay, so the thing on top is going to be the subject and the thing underneath is going to be what is in your answer, a function of that thing. So you're going to end up with something here where x is equal to some function of t. Okay, x will be in terms of t. So how do we solve differential equations? Well, we've been doing that since, you know, what we did early in AS maths. Like for example, when you had dy dx equals x squared minus, 5x. All right, then we solved it by basically integrating both sides. Okay, integrating. I mean, the way we thought about it is to get what y is, you have to integrate x squared minus 5x with respect to x. Okay, and then you integrate this and you got your answer. All right. For us to really understand what's happening with differential equations, I'm kind of taking a bit of a side point here just to make you understand the basics of why we do what we do when we solve differential equations, so that you don't just do something that you don't understand why we're doing it. Okay, I want you to understand the basis behind it. And these are things that we don't normally write down. Like what we don't normally write down in something like this is we don't normally write down the fact that what we're doing to one side of the equation, we're going to do exactly the same to the other side of the equation. Just like when you solve in any type of equation, you have x plus 3 equals 5. what we do to one side, you have to subtract 3. You do to the other side, so you subtract 3, you get 2. Okay, if you've got like a 2x plus 3, then you have to also divide both sides by 2, so you'll end up with x equals 1. So whatever you do to one side of an equation, you do to the other. Okay, so the same goes for integration or solving differential equations. Okay, so this is actually a differential equation. We never called it a differential equation before, but it's actually the basic form of a differential equation. We start off with something which is, you know, a rate like dy dx, and you end up with something without that rate. You get rid of that, and you have y in terms of x in the end once you've finished. But the process behind this, which we don't write down, and I don't expect you to write this down even, but just for your understanding of where what we do comes from, actually what we're doing here is we are integrating both sides with respect to x. So I integrate this side with respect to x. I also integrate this side with respect to x. Okay, so when you do that, you can say those cancel out, and you've got the integral of, basically there's a y here, you end up with integral of 1 with respect to y equals the integral of x squared minus 5x with respect to x. So that's where you end up with this y. If you integrate 1 with respect to y, you get y. So this side you integrate with respect to y in the end, because the dx is cancelled out. That 1 becomes a y, and then you have, you know, to integrate this with respect to x. So you end up with x cubed over 3 minus 5x squared over 2 plus c. Alright, so this stuff here, we don't normally write it down. We normally go straight from here to there, basically. Alright, so but that's basically the mathematics of what's behind going from here to there. Alright, so if you understand that, if you understand exactly what was actually going on, which we don't normally write down, you will have a better appreciation of what's happening when we're solving differential equations. Okay, so let's apply that to this. Alright, so if you want to integrate this, or you want to solve this differential equation, you always integrate with respect to the denominator of the rate. So I'm going to integrate both sides with respect to t. So this is going to be integrated with respect to t, and this side is also going to be integrated with respect to t. Okay, now as you can see, this is going to cancel out, and we're left with something here. This side has to be integrated with respect to t, and this side has to be integrated with respect to x. So on the side that you have the dx, all the x terms must go. So these terms must end up on this side. So you end up with (10 minus x) times 20 minus x. Okay, let's put 1 on here for now with respect to x, equals, and this is going to be the integral of 1 over 100. I'll write it like that for now, dt. Okay, so on the side that you have the dx must go, the x terms must go. On the side that you have the t terms must go. There's no t terms, so you can leave the constant here, but what I think will be easier here is actually to multiply both sides by 100 to end up with this becoming 100 on top here, and then you end up with the integral of 1 with respect to t. Okay, so now we want to integrate this with respect to x, and this side with respect to, this is no problem. This side here, we have to try to rewrite it in such a way that it can be integrated. The way it's written now, it can't be integrated. So we have to have a skill set of knowing how to integrate such type of expressions. Now, in order to integrate this, what we must do is, in this case, split it up into a pair of what are called partial fractions. You have two linear factors, so I'm going to take a little kind of like a detour now, split this up into partial fractions, and then go back and answer the question. So I know that this is identical to some constant over one of the linear factors plus another constant over the other linear factor. It's like we're trying to take this fraction and seeing what it was before those two fractions were added together. Okay, two fractions were added together to give us that. We want to find out what it was. So there's going to be a constant here and a constant there. Okay, that's how, if there's a linear factor in the denominator like this, then on top of it has to be something which is less than that, okay, which is of an order less than that. So there has to be something here which is a constant and something there that's a constant as well. So now for us to find a and b, what we can do is we can multiply through by 10 minus x times 20 minus x, in which case you get 100 on this side, and here you're going to multiply this fraction by 10 minus x times 20 minus x. The 10 minus x cancels out, so you're left with a times 20 minus x. And if you multiply this by 10 minus x times 20 minus x, the 20 minus x cancels out, leaving you with b times 10 minus x. Okay, it's like basically this multiplies with that, that multiplies with that. That's what it looks like in the end. So now what we can do is to find what a and b is, we can use some sort of elimination technique. For example, if I replace the x with 10, all right, then this term b term will be multiplied by 0, and you're left with the a term. So this, if you replace x with 10, you have 100 equals, this is going to be a times 20 minus 10, which is 10, plus 0. So you're left with a is equal to 100 over 10, which is 10. And if we choose x equals 20, in that case, this bracket will become 0, the a term will be eliminated, and we will end up with the value of b. So 100 is equal to 0 plus, and you're going to have 10 minus 20, which is minus 10. So it's b times minus 10. So you end up with 100 divided by minus 10. So b is equal to minus 10. So that's a and that's b. So now we can write down that this is actually equal to 10 over 10 minus x minus 10 over 20 minus x. So that's what this will become. So I can now rewrite this integral as 10 over 10 minus x minus 10 over 20 minus x. So I end up with 10 over 10 minus x minus 10 over 20 minus x. That has to be integrated with respect to x, and on this side you have 1 integrated with respect to t. Now from here there's different ways you can proceed. I like to use the method that I'm going to show you now, all right, where I'm not going to use an indefinite integral. I'm going to use a definite integral because I have a pair of values that are going to help me, and that will automatically work out the value of c that I would have had to write if I was going to use this as an indefinite integral. So what I can say is, it's a nice little neat way of doing it. I want to find x in terms of t. I know that when x is 0, t is also 0. Okay, so if you have a pair of values, you can put them in the bottom part, and you're trying to find x in terms of t. This will automatically work out the value of the constant of integration. Okay, which will make life a bit easier, I think. Okay, if you don't want to do it that way, you can integrate, put plus c at the end, work out what c is, and you'll get the same thing in the end. I personally prefer to use this method. So don't forget, we need to integrate. A lot of people forget about that. So when you integrate something like this, you have something where the denominator, if you look at it, if you differentiate, you get a constant. On the numerator is a constant, something of this form, f dash of x over f of x. Something of that form. So if the numerator is a form of something which is of the same order of the differential of the denominator, you can integrate it using the ln. So it will give you, if you integrate something like this with respect to x, you end up with a ln of the modulus of whatever's underneath. Okay, that's the basic form, right? Because when you differentiate ln of, if you differentiate ln of some function of x, you end up with 1 over that same function of x times the differential of it by the chain rule. So we're reversing that basically. So when you integrate this is the way I like to do it. I'll leave the constant as it is. I'll put times the ln of the modulus of 10 minus x, but then I've got to divide by the differential of what's inside this function, which is minus 1. Okay, and here I have minus 10 times the ln of the modulus of 20 minus x divided by the differential of what's inside the function, again, which is minus 1. I have my limits as x and 0, and if I integrate 1 with respect to t, I'm going to get t, and my limits are t and 0. Okay, so now this gives me minus 10 ln of the modulus of 10 minus x and you're going to have here plus 10 times the ln of the modulus of 20 minus x, and this is equal to t. And I can in fact divide both sides by 10 just to get rid of the 10 on this side, so I'll end up with 0.1 t, and here I'm going to end up with the ln of the modulus of 20 minus x minus the ln of the modulus of 10 minus x. I can combine these together into 1. So this is the ln of the modulus of 20 minus x over 10 minus x. Now I've just forgot to put a few things here. Okay, this is t and 0, it's going to give you t. I've still got my x and 0 to use for this. I'm going to put them in when I've got it ready. Okay, so I've used the law of logarithms. Now I'm ready to put these limits in, and that will automatically give me what c is basically. So now when I put x into here, of course I'm going to get the ln of, now you got 20 minus the modulus of 20 minus x over 10 minus x. Okay, minus, when you put 0 into here, you have the ln of 20 over 10. Okay, if you put 0 into there, you get 20 over 10 equals 0.1 t. So this gives me the ln of 20 minus x over 10 minus x minus the ln of 2, okay, equals 0.1 t. All right, now I can use division here, the division law. So this 2 can be like, this will be 20 minus x over 10 minus x divided by 2. So I end up with the ln of 20 minus x over 2 times 10 minus x in the denominator equals 0.1 t. And now what I can do is I can make, so we have to, it just says solve the equation. Does it tell us how to express it? No. So what we're going to do is we want to make x in terms of t. So I'll make x a subject. To do that, I have to free the x's from this ln. So I'm going to rewrite this in index form. Now what we know is ln means a log to the base e. Okay, so if you have log to the base e of something, for example, log to the base e of a equals b, I can rewrite this in index form, e to the power of b equals a. This is the base, that's the power, and that's the result. So I can rewrite this as, remember there's an e here which is not written, so I'll say e to the power of 0.1 t is equal to 20 minus x over, I'll put 20 minus 2x. I'll just expand that at the same time. So we want to make x a subject. To make x a subject, I've got to rearrange this. So I can multiply both sides by 20 minus 2x first. So I have 20 times e to the power of 0.1 t minus 2 times 2x minus 2x times e to the power of 0.1 t equals 20 minus x. I want to make x a subject, so I'm going to bring the x terms on one side of the equation. So what I can do is I can say x minus 2x e to the power of 0.1 t equals 20 minus 20 e to the power of 0.1 t. So I've added x to both sides and taken away 20 e to the power of 0.1 t from both sides. Now I can make x a subject of this. So I have 1 minus 2e to the power of 0.1 t equals 20 minus 20 times e to the power of 0.1 t. And then finally I can make x a subject and say x is equal to, I can write this, take this out maybe, 20 minus times 1 minus 2 e to the power of 0.1 t divided by, and here I'm going to have 1 minus 2 e to the power of 0.1 t. And there is the answer, and the value of c is automatically calculated. Okay, this is probably what it would have been if we integrated, and then we put the value of plus c. You know, if it was an indefinite integral, you'd write plus c at the end, and you work out what c is, it'll probably give you this. Okay, so either way is fine. I just prefer to do it in this one swoop kind of thing. All right. So there's the answer to this question, part B. So we've written x in terms of t. Okay. Then part C says state what happens to this value of x when t becomes large. Okay, now there's it's only worth 1 mark, so you just have to write down the value that it becomes, approaches. Okay, so what we can do here is we can actually do a nice little trick, and then I'll explain to you the actual algebraic way of dealing with it. But if I put this into here, 20 times 1 minus, sorry, that's not, there's a mistake here. Yeah, that's supposed to be a 1 there, sorry. Okay, I've just sorted that out just in time. Okay, I don't know why I put 2, because that's 20 minus 20. Yeah, there's supposed to be a 1 each. But anyway, so let me just get rid of that. Okay, so you got e to the power of, so you can put shift and this 0.1 times. Now what you can do is you can choose t as a large number. Like let's say we choose t as 1,000. All right, just to, we can go large if we need to later. 1 minus 2 times e to the power of 0.1, and I'm going to put times again 1,000. Now that should give us the value that this expression approaches when t becomes something large. As you can see, it approaches 10. Okay, it approaches 10. Okay. Alright, so we can see that as t becomes very large, then x approaches 10. Now, what is the algebraic way of showing this? Okay, what's the algebraic way of showing this? Well, what we're going to show you here, I'm going to show you that here, is as follows. And that's going to be in the following way. So basically we have here 20 times 1, let's do it like this, 20 minus 20 e to the power of 0.1 t divided by 1 minus 2 e to the power of 0.1 t. That's what x equals. Now if I divide both the numerator and denominator by e to the power of 0.1 t, so that will become 20 divided by e to the power of 0.1 t minus 20 divided by, this is going to be 1 over e to the power of 0.1 t minus 2. Alright, that's what we're going to get. Now what we can see here is as t becomes really big, then e to the power of 0.1 t, we can write it like this if you want to be more mathematical. We can say that the limit as t approaches a really large number of 20 over e to the power of 0.1 t is going to be 20 over, this is going to be a really big number, which is going to be 0. The limit is going to equal 0. It's going to get towards 0. So basically, the same for 1 over e to the power of 0.1 t. Same thing. The limit as t approaches infinity of this is going to be 1 over infinity, which is going to be approaching 0. So both of these will approach 0. So we can say that, let me write it over here. The limit as t approaches infinity of this is going to be minus 20 over minus 2. This will be 0, this will be 0, and that's going to give you 10. Okay, so that's what it's going to approach as t becomes something which is really, really big. All right, so that's how we can understand how to answer part C. If you just stated what this was, that as t approaches infinity, x is going to approach 10, that's perfectly fine. You will get the 1 mark. You can just write x will become 10. Okay, x becomes close to 10. That will give you your mark. All right, that's fine. All this stuff here is just a bit of an explanation of why, but your calculator will give you 10 if you just put the values in as you saw. Now sometimes you might put in your calculator and it comes out and it says math error. That's if you put in a really large number, for example, the calculator can't deal with. So if I put a really large number in these places, it will give you math error. So sometimes you might have to just put a smaller number in, less zeros, to, you know, get a sensible answer in the end. But that's how you basically deal with this question, and that's the end of the paper. That's it. That's the end of this paper. I hope that was clear. Okay, as I said, I go into a bit more detail sometimes, especially in explaining this differential equation part, because I like my students to understand the reasoning behind why we do things. Okay, so you know, many students will just say, oh, we have to put the dt there, put the x's down here, integrate. I mean, that's basically what we did in the end, right? But I like you to understand the reasoning behind it, where it comes from. Okay, so that's why I gave you, if you don't write those things down, there's no problem. Important thing is understanding what's happening. So there we have it. That's the end of this question and the end of the paper. Other questions from this paper can be found in the playlist, which will appear in the top right of this screen at the end of the video. Other questions from this topic of differential equations from P3 of Cambridge can be found in the playlist over here. Differential equations from the playlists of Edexcel you'll find in the playlist over here. You can subscribe to my channel by clicking on this link. One last point, that the answer we got here, it could have been written the other way around. I can have it as, you know, 20 e to the power of 0.1 t minus 20 over 2 e to the power of 0.1 t minus 1. Both of them are fine. It just depends on which side you decide to bring the x's. If I decided to bring the x's like on this side, okay, then I would have got this answer. Because I decided to put the x's on this side, I end up with the same thing. Okay, it's like if you have minus 2 over 3, or you have 2 over minus 3, they're both the same thing. So these are the same thing. And you'll see the same, you know, value you'd reach even if you put them the other way around. Okay, it's like you multiplied both top and bottom by minus 1, that's all. It's a little side point. Anyway, so I hope that was clear. Thank you for watching and see you soon.